the Pascal triangle. The Pascal's triangle so we are going to discuss about this Pascal's triangle based upon the coefficients of various terms in the expansion of the binomial in an advanced level. So here let us suppose a binomial as a plus b, in which the first term is of a and the second term as b. Then now in the given below binomials, say a plus b whole to the power of 0 is equals to, since the exponent is of 0, therefore anything raised to the power of 0 will be of 1. Then now the second one, a plus b whole to the power of 1 is equals to, so here bracket whole to the power of 1 will be of again a plus b itself. Then now the third one, that is a plus b whole square is equals to, as per the special product, so it is of a square plus 2ab plus b square. Then by observing this binomial, that is a plus b whole cube, its expansion form will be of a cube plus 3a square b plus 3ab square plus b cube. Whereas in all these cases, that is case number 1, 2, 3 and as well as 4, the binomial is of a plus b in each and every case, and if the exponent of this binomial is of 0, then the coefficients of the various terms is of 1, and if the binomial's exponent is of 1, then the coefficients of this various terms, that as a and as well as b. So here the coefficient of a is of 1 and b's coefficient is also of 1. The binomial a plus b, if it is of raised to the power of 2, that is a plus b whole square, its expansion is of a square plus 2ab plus b square. If the exponent of the binomial is of 2, then the coefficients of the various terms are of a square's coefficient is of 1 and ab's coefficient is of 2 and b square's coefficient is of 1, that is 1, 2 and 1. So next binomial is of a plus b whole cube. So here the exponent is of 3, therefore the expansion will be of a cube plus 3a square b plus 3ab square plus b cube. Since the exponent of this binomial is of 3, then the coefficients of the various terms are of a cube's coefficient is of 1, then a square b's coefficient is of 3, ab square's coefficient is of 3 and b cube's coefficient is of 1. That is, when the exponent of this binomial is of 3, then the coefficients will be of 1, 3, 3 and as well as 1. Then now, so here let us write the coefficients of various terms in the expansion of binomial to the various exponents as per the table. Then we have, so here let us write in the first column as exponents of the binomial. Then now, whereas in the second column we are going to write it as coefficients of various terms in the expansion. So here already we have discussed that if the exponent is of 0 as per the conditions which we have discussed here, if the exponent is of 0, then the coefficients of the various terms will be of 1. So here it will be of 1. Then if the exponent is of 1, then as per the condition, if the exponent of the binomial is of 1, then the coefficients of the each and every term, that various terms will be of 1 and 1. Then in the next case, if the exponent of the binomial is of 2, then we will be getting it as, so here by adding up 1 plus 1 is of 2, then the bounded coefficients will be of 1 and as well as 1, that is 1 to 1. So as per the condition, if the exponent is of 2, say here 1 to 1 are the coefficients of the various terms. Then now if it is of 3, the exponent coefficient is of, the exponent is of 3 of the binomial, then the coefficients of the various terms are of 1, 3, 3 and 1. So here we will be getting it as, so we are going to suppose the exponent as 3, then now here we have to add up 2 and 1 and 1 and 2, then we will be getting it as 1 plus 2 as 3, 2 plus 1 as 3, then on either side it is bounded by means of 1 and 1. Then now if the quotient is of 4, if the exponent is of 4 of the binomial, then now the coefficients of the various terms will be of, so we have to add up these two, 1 plus 3 and 3 plus 3 and 3 plus 1. Then now, so we will be getting 1 plus 3 as 4, 3 plus 3 as 6, 3 plus 1 as 4. Then on either side we will be adding the 1 and 1 as the coefficients. So therefore, when the exponent of the binomial is of 4, then the various terms coefficients will be of 1, 4, 6, 4 and 1. Then the similar manner, say if the exponent of the binomial is of 5, then we have, so here 1 plus 4 and 4 plus 6, similarly 6 plus 4 and as well as 4 plus 1. Therefore 1 plus 4 is of 5, 4 plus 6 is of 10, 6 plus 4 is also of 10, then now 4 plus 1 is of 5. On either side we have to attach 1 and 1 as the coefficients. So here when the exponent of the binomial is of 5, then the coefficients of the various terms will be of 1, 5, 10, 10, 5 and 1, and similarly and so on. So here we can write it as, so here the note will be of here in each row of coefficients is bounded on both sides by means of 1. So here this arrangement of coefficients will be called as the Pascal's triangle. So here hence The above arrangement of coefficients is known as Pascal's triangle, or in other words, it can also be called as arithmetic triangle.